Adjunct Professor Moran, Macroeconomics 111. We're going to cover the monetary equation of exchange now. Economists use an equation made famous by a famous economist, Irving Fisher, to show the relationship among money, price, and real output. It's called the equation of exchange, and it takes the form MV equals PQ, where M is the amount of money in circulation, M1, M2, M3, for example. V is how often a dollar changes hands. Believe it or not, if GDP is $20 trillion, you don't need $20 trillion in circulation. That's because a dollar is spent more than once in an accounting period. Here's some studies of how often a dollar changes hands. And it's about, for M1, about 8 times in an accounting period. So you would need 1/8 of GDP in order to accomplish that amount of trade. All right. P is the rate of inflation, and Q is real GDP. So nominal GDP, P times Q, inflation times real output, gives you nominal GDP. So Q would be like Q is real GDP, and this is the rate of inflation. Taking real GDP and multiplying it by a price index would give you nominal GDP. Nominal GDP has to be equal to the money supply times how many times a dollar changes hands in a period. This equation attempts to show the balance between money, which is represented on the left side, MV, and goods and services, represented on the right side, price level and the actual real quantity of goods produced. For a given real level of income velocity, V, if the supply of money grows faster than real output, then what's happening is some of that increase is going to leak into inflation. Then there will be inflation in the economy. Classical economists assume that the velocity of money was stable. So for this to work, V has to be constant. Over time, because of institutional factors, such as how frequently people are paid, largely determined velocity, which does vary over time, though, because now you don't have to go to the bank to get your money on payday. There are other ways of getting your money, for example, ATMs. Define the 4 variables used. So M is the money supply, V is how often a dollar changes hands in an accounting period, and that will equal a dollar, if it changes hands 2 times, can generate $2 worth of GDP. And then on the other side is real output, maybe $10, but if in the next accounting period, if inflation, if we still have the same amount of real output, but there's inflation of 10%, then PQ would be 11. So PQ is, if this is GDP real, and this is inflation, then these two things are GDP nominal, GDP unadjusted for changes in output. If the velocity remains constant while the money supply increases, then this side of the equation has to increase too, PQ. Is it going to be an increase in real output, or is it going to be an increase in the rate of inflation? It depends according to these monetarists. They're going to want, these monetarists are going to want MV equals PQ. They're going to want to find out what this change in real GDP is. And they're going to want to increase the money supply accordingly. Otherwise, if V is constant, otherwise if you increase this at 5%, it's only growing at 2%, then you get 3% inflation, for example. It'll bleed out into the other variable. So these people want to match the growth of the money supply with growth in real output. That's the purpose of what they're trying to do. Okay. During the past 30 years, credit card use has increased, and financial institutions have used computers for transactions and used ATMs. As a result, it's easier to get a hold of your money, and so in the long term, the velocity of money has increased. Here are some examples of actual MV equals PQ data. And so we're going to calculate them. To see how the formula works. Okay. Okay, so here's MV and PQ, and here's the product of PQ. Notice that For this purpose, they're using a base year of 1996, yes? Whenever the index is 100 or 1, that's the base year. Before the base year, during a period of inflation, the index will be less than 1, and after, the index will be higher than 1. All right. So 750 times 6.36, let me see, carry the 7, it comes out to $4,768 billion. What's 0.78 of 6114? $4,768,000. All right, so the next year the velocity was constant, slightly increased, and nominal GDP increased by 2.2 trillion. Real GDP increased 1.1 trillion. So there was inflation in that year. Okay. Well, if this times this equals these two numbers, and these two numbers equal that number, to get the velocity of money, we will divide 5,489,000,000 by M, the supply of money, which is 792. And doing that, we will discover that the velocity of money is 6.93. Similarly, if this number and this number equal this number, then we'll take 5,489 and divide it by 6597. And we'll get 0.83. If we're missing the supply of money, if this times this equals this expression, and this expression equals this one, they're just doing the arithmetic for you. All you have to do is subtract, divide the product, this number, by velocity. So we're going to take 739310 divided by 6.57, and we'll get 1125. Okay. So the supply of money is gradually increasing. GDP is increasing. All right, here's one we haven't done. So to get this number, you can either multiply these two, or you can multiply these two. So 1097, 7.99. Multiply them together. You get 876503. Alright, so that's practically calculating MV equals PQ. Holding the velocity of money constant, if you increase, you should try, they want to recommend increasing the rate of increase in M1 with the change in real output. But if M grows faster than real output, it will result in higher rates of inflation. But this won't work if the velocity of money changes. And you can see that over time the velocity of money is in fact changing. It's growing because of institutional factors, such as banks making it easier to get your money. When I was a kid, you would get paid in person and take your money to the bank, and the banks closed at 6 p.m. So you had to get there before 6 p.m. and got off of work at 5. And the rest of the week, the bank was only open until 3 o'clock. And if you got out of work after 3 o'clock, then you didn't have money. So that would definitely slow the velocity of money and keep it constant. But because of institutional changes, as we discussed, direct deposit, ATM machines, credit cards, you can increase the velocity of money as a result because of these changes make it easier to get money. All right, so that's the velocity of money and its function.